Welcome to today's episode of Building Connections, and today I'm having a conversation with Paul Smeets of one of our longest partners, actually, Cadac, CTO with the company. I would say this is first line introduction, Paul. Would you like to introduce yourself and explain or tell a little bit about what you're doing and what your company is doing?
Sure. Yeah, nice to be here, Erik. First of all.
Yes, it's mutual.
My name is Paul, as you know. I'm a proud father of two sons, 28 and 25. I'm 55 years of age, and I live in the first hill of the Netherlands. In the south of the Netherlands, so
I know it's a beautiful place. Actually,
it is. I'm 100 meters above sea level, so
you're safe.
I'm safe. Whatever happens in the future, I'm safe. So, yeah, and I'm the CTO for a company called Kdeck, and I've been with the company for over 25 years. The company's 36 years. We just had our anniversary celebration, so we've been there for 36 years. And a lot has changed over the last decades, and my role within the company, I've been there, as I said, over 25 years, and my role within the company is to make sure that we have the right strategy for our products, for our services, and that basically sums up what we do. Is we as a company do three things. We build software, we do consultancy, and we resell software mainly for Autodesk. So we are one of the biggest partners of Autodesk in this region, so that's what we do. And our solutions are all around making sure that everything you see around you, machines, tables, buildings, roads, can actually be produced or be built, and everything you need in the design process to make sure that you can build stuff. And that's because coming.
Coming to your company, I think it was even pre-COVID. I think that you had this production line there as well, automated. So actually, to explain in simple terms what you actually are doing in the market, it's about computer-aided design and manufacturing, right?
Yes. That's correct.
And effectively, that's the basis of our collaborations over the past years, of course, because we rely a lot on Cadac's advice in how to deal with elements around BIM.
Yeah.
And that's, of course, the topic of our conversation today and other things, probably.
Yeah.
You know?
Yeah.
So I think the topic of BIM has been in, let's say, the real estate operations and facility management industry. I think we started conversations, it must be over 10 years ago, well over 10 years ago. And it has found a certain element of adoption already. But just as a question to you, how do you currently look at the use of BIM in the frame of building operations and lifecycle management? What do you see happening in the market today?
Well, first of all, the adoption of BIM, we met over 10 years ago and we started our conversation around BIM, and we expected it to be predominant in a few years' time. And to be honest, that hasn't really happened. Only, 50%, I don't know the exact numbers, 50% of all construction companies are using BIM in the construction phase. So taking BIM to the construction site. So that's a pretty low number. And even just 30% of all construction projects are on budget and on time, or within a frame of about 10%.
Right.
And there's probably a connection between the low adoption of BIM and the fact that construction is still struggling. BIM hasn't fulfilled the promise that we thought it was going to fulfill.
At least in the time frame that we thought it would be.
It's much slower, I think, than the adoption has been much slower. I mean, the adoption in the design phase has been pretty rapid. I mean, it doesn't need any explanation that to coordinate stuff in the design phase, you need to work together in a 3D model. So adoption in the design phase has been good. Transferring information from the design, from let's say the engineer's desktop to the actual site, the building site, that's still something that's struggling. And that's one of the facts, that handing over information that needs to be as built from the construction site to operations, That's where you see a decline of adoption of BIM.
Yes.
And that's one of the issues looking at handing over information to the operational phase is the simple fact that there is no as-built information because we mess up stuff after designing it and bringing it to the construction site. There's
interesting because when you look at design, and I think currently in our industry we talk about buildings as stores of material. A material store. So that's of course when you're using a building for 30 years, you're going to take out the stuff again in 30 years from now. But it also predominantly requires the design, so I'm moving back to design, the design of the building to be done in such a way that you later on can disassemble it again. But actually, when you basically do a good design, you are not constructing, but you're assembling a building.
That's right.
Something I seem to notice in the market, at least, that this is getting some attention. So what's your view on that?
I mean, there's circularity and there's environmental stress that buildings put on their environment or producing carbon or whatever. So that's one aspect. The aging workforce. I mean, I'm not sure if you ever try to redesign or to reconstruct or to do something in your own house. It's quite a challenge to find people that can actually do stuff.
Yes.
So bringing construction to the factory is probably it's inevitable. If you want to be able to build high quality buildings with the declining workforce we need to bring stuff from on-site to the factory. So that's that's one of our main things is that we focus on both manufacturing and construction. And what we see is the convergence of those two. Construction is becoming more and more a manufacturing process. And with that manufacturing process, you can think about standardization, you can think about modularization. And that makes it easier to construct stuff that can be disassembled again. So smart modules instead of doing stuff on site that is impossible to disassemble or to create a circular kind of approach to design.
But actually, so it could potentially perhaps then work two ways, because if you're going to design to disassemble, so to say, the design is very eligible for assembly instead of construction. That might stimulate constructors to adopt BIM, because then you have much more value out of the model, because you're not going to do the standard concrete work, for instance. I also just read under the climatic situation, the deposits of CO2 emissions and deposits of hydrogen type of materials. One of the statements made by constructors was, we want to take manufacturing to a factory because there we can control our our emission profiles and so on, and we actually want to assemble there. And if you look at that approach, that's creating more sustainable buildings, but also perhaps even, that's what I read as well, the increased interest in using wood as a construction material with embodied carbon. So you're basically putting carbon in the building instead of making it a kind of emission type of thing. So there's a lot of market drivers, but actually, would it be fair to say that architects and designers should adapt their designs to enable assembly?
I'm all for it. I mean, instead of looking at a building as a work of art, I mean, don't get me wrong. Then there's an absolute need for beautiful architecture, and then there's a need for beautiful buildings. And in some cases, you need to consider a building as a work of art, which is good. But let's be honest, 99% of all buildings that we make shouldn't be a work of art. They should be comfortable. They should be have a low environmental impact. They should be circular. They should be fit for purpose.
Right.
That doesn't mean they have to be ugly. I mean,
I get it.
Not necessarily, anyway.
I get it.
So, looking at the building rather as a product that is prefabricated and manufactured in a controlled environment with a low environmental impact, and simply making stuff smarter.
Right.
Is very important. Is I think a big shift in construction.
Right. So actually, a point could be that when design practices change, the inherent consequence, or let's say follow-up step, would be adoption by constructors. If that's going to be the case, the adoption for the life cycle is facilitated a lot.
Yes.
As well.
Yeah. I mean, the biggest problem, as I said, is not having as-built information.
Right.
If you prefabricate stuff or you standardize stuff, you know a lot more about how it was produced, in what environment it was produced, what did you make. So there's a lot of information. I mean, in manufacturing, we know a lot more about machines than we know about buildings in construction.
Right.
And one of the reasons is that we repeat stuff and that we learn from our mistakes. Well, learning from mistakes is still something that's not common practice in construction.
Right.
Because we reinvent the wheel every time.
Yeah.
And it's not as if I look at the buildings around me as if everything looks like a work of art.
Right.
In many cases, it is a repetition of stuff that I've seen before.
Yes.
Just re-engineered time and time again. So stop reinventing the wheel and start reusing what we have and start learning from what we did. That's the biggest point, I think, in construction. The only way to do that is to have a more manufacturing approach to construction than a typical construction approach to construction.
Right.
Yeah.
Because I think, by the way, as a background, the backdrop of this next question, I used to be, I think 25 years ago, used to be information manager for Philips Machine Factories, which is now Van Lande Industries. So high-tech manufacturing, mechanical engineering and manufacturing stuff. And it's my today's perception that still that industry so long ago was effectively ahead of the construction industry today.
Yeah.
Now, to the question, what do you regard the best lessons that the building industry and construction industry can learn from mechanical, electrical manufacturing industry in terms of this?
Yeah, I think we need to start looking at a building as a product. That's one. But we also need to look at a building as a system of systems.
Right.
So we tend to look at a BIM model as an assembly of objects, things that we put together, be it in a factory or on site. But it actually is not a assembly of dead things. There's a design intent behind it, and that design intent is translated into systems, heating systems, MEP systems, electrical systems, sewage systems. So looking at a building more from a functional requirement perspective is important to design the right systems, and this system knowledge or this system information. Why did I design the heating system the way I did? Is crucial for the operational phase, because if we lose whatever functional requirements I had up front, which is normal in the process industry and the manufacturing, if we lose that information and we have 1 or 2 years of design and construction and then we go into 30 to 50 years of operations, you know that there's massive change happening in those 30 to 50 years.
Right.
If we don't have the information about the design intent, the systems that we designed, and we just look at the building
as a static thing,
as an assembly of objects, and I start taking out pumps, and I know everything about that pump, who's the manufacturer, what's the capacity, but I don't know why it's there, because what's the function of that pump within
the bigger system,
in the system.
Right.
So having in that sense, I think the BIM model, the 3D model, is overrated.
Right. Or you could state that you actually, what you need to do is put in the dynamics in the static design of the 3D.
Definitely.
So that you basically see its operations, that you can basically understand the relationships between the different components of that building.
Yes, and that's what we've done. I mean, there's been SCADA and MES systems and what have you in the manufacturing industry that allow a real-time insight. We didn't call it digital twins back then, but...
No, we'll talk about that later.
but I mean, it is if there's a red light flashing on a control board in a process industry, you know that there's something wrong.
Right.
Nowadays, we call that big data, and we call that IoT, and we call that digital twins. But it's simply making sure that you look at it, that you perceive the building as a system, and that you know how the system operates.
And understand its dynamics.
Sure, and combine that with a 3D model or an assembly of objects that we call the BIM model.
Right.
And that's with the chemistry of those two, data from operations, data from the early design phases, together with the 3D model, then you have, I think you have the starting point for a digital twin.
Yes, you're pointing at digital twins that we will talk about, but I will one step back before we move into that.
Sure.
And that's, as I said in the introduction, you're very much around computer-aided design and computer-aided manufacturing. Mm-hmm. Now, when you take the computer-aided manufacturing into view as it pertains to manufacturing, because what is there today for constructors to help them manufacture their components from a design? When let's say it's being designed well. In mechanical engineering, I know it's there, it's already for years. What is there for the manufacturing industry in terms of buildings?
Well, first of all, you need to get away from the fact that you want to engineer everything. In construction, there's been in manufacturing, there's been a transition from what we call engineer to order.
Yeah.
The space shuttle is a typical engineer to order product. So the engineering costs to build a space shuttle, the engineering costs per unit are massive. So there's a big effort to build a space shuttle.
Right.
In the construction industry, look at a car or consumer products, the engineering costs per unit are very low. And how do we do that? By standardizing and by mass customization, by all kinds of... We want to serve the consumer with a unique product, and still we want to use standardized products.
Right.
So the engineering costs per unit are pretty low.
Right.
And now there's construction. We want a space shuttle, but we don't want the costs that are associated with constructing a space shuttle.
This unique design.
We need a unique design, so we want to build a space shuttle, but it shouldn't cost more than an average car.
Right. It doesn't match up.
It doesn't compute. That doesn't work.
So it's standardization of components, of construction elements.
Yes.
And then you can basically standardize your manufacturing.
Yes.
And then you can go into a type of assembly approach.
Yeah, you need to be smart. You need to have a product approach. You need to design smart modular systems. And you don't want to end up in Eastern Germany in the 50s, like the ugly one-size-fits-all things.
Yeah, that's it.
I think you don't have to.
No.
But the design challenge that we that architects need to pick up, that's my personal opinion,
right,
is that they be creative within certain boundaries.
Right.
Be creative and still use standardized elements, or be creative and reinvent systems or modular systems.
It's almost like Lego, you know. I need another. Can you standardize a new component for me so I can make a new structure or a new design or something? But standardize it all.
Standardize it again. So you know how to do it. You know how to learn. We talked about it a few minutes ago. You know, if something is wrong, don't reinvent it completely from the scratch, but
make it better.
Make it better. And the only way to learn is to have operational data on those elements and know how they
from the life cycle
exactly and get all kinds of data from the operational phase of the building and feed that back into the design phase.
Right.
And that's industry 4.0 or whatever.
Yes.
That's what we call it in manufacturing.
Yes.
But if you don't close the loop from operational stuff, how does it work? Is the system really bringing 20 degrees of and a certain humidity?
Right.
I don't know, if we don't get that back into the design phase, we're not able to close the loop. We're not able to learn, and we're going to keep on making the same mistakes.
Globally.
And I mean, in manufacturing, there's something going on like servitization, where a customer doesn't buy the machine.
No.
They buy functionality, packaging, or I don't know, transportation or whatever. So it's up to the manufacturer to make sure that he produces a machine that does that as efficient and as high quality as possible. Yeah, I think that's going on in construction as well, where we need to consider how do I bring the best value, not a work of art, but the best value to the occupants of a building.
Right.
And the only way to do that is to make sure that you know how to improve whatever you do.
Yes.
And the only way to
learn from experience.
Yeah. And you cannot improve if you keep on doing stuff the first time in your life.
Right.
You need to learn from your mistakes.
Yes. Yeah. Thank you. Let's go to the topic of digital twins.
Yeah.
Because we already had a lead into that. Perhaps when I would just simplify it, BIM models in the building industry, of course, BIM models are often being, let's say, identified as this is a digital twin.
That's BS.
How do you look at the relation between BIM models and digital twins? How do you look on the subject of digital twins for the built environment?
Yeah, well, first of all, you have to, digital twin is kind of a container thing. I think digital twins in the early design phases are very well equipped to do what-if analysis and stress analysis and maybe even flooding analysis. And if you look at the broader context of where a building is situated. So a digital twin in the design phase can help you make the right design decisions.
Right.
And that's connecting the BIM model to all kinds of software that helps you calculate stress and flooding and whatever, and simulate it
so it's simulation. So
it's basically simulation to make the design.
For virtual simulation of what might happen, or how the building operates in terms of its systems and connectivity of systems.
Exactly. Yeah. And then if you bring it on to the next phase in the life cycle, is actually constructing it.
Yeah.
Then a digital twin can be very useful in managing logistics. What's the progress I'm making? When do I need the next element from the factory to be brought into my construction site and to assemble it?
Assembly site.
Yeah, the assembly site is a better word. Yeah, exactly. and do quality control and actually record whatever you do on site. So in the operational phase, you know that if stuff has gone wrong, you can actually point at it and you know where the root cause of your problem is. So that's where I think digital twins in the construction phase come in to record progress.
Right.
And to make that progress available to everyone who needs to take decisions around logistics and what have you. Yeah.
Right. Then the model is actually, let's say, digital manufacturing for construction.
Yeah.
Now we take the model to operations, and it seems to take a different type of shape, actually, or a different type of purpose, so to say, when you operate the building.
Yeah.
And in terms of when we basically put this notion of digital twins ahead, I would like to challenge the idea a little bit that BIM takes the same role as you look at digital twin concepts. We've been thinking about it as well. But a digital twin, let's define it as a virtual representation of a physical thing.
Yeah, and the physical thing, that's something, where stuff? The answer to the question, where is stuff? That's where the BIM model comes in. But
it's where, but when you go to operations, you add things to it that might be even more relevance almost, is how is it operating today? What's its condition? Can we do some, let's say, prediction on how it's going to be behaving in the future?
Yeah.
And I would like to challenge you a little bit on this. I think, as we have been thinking about this, the phenomena of digital twins for building operations, I have the impression today, as we move into the field, because that's new, that digital twins are actually might not need a visual representation
I fully
at all.
agree.
And actually, that when we would only say digital twin is something that I can look on and look at, is actually taking away a very important part of what the digital twin can bring to the industry, and that's automation and decision automation. So just to give an example, we're going to monitor the HVAC here. Something is going wrong. I can look at it and I see a red HVAC, and when I look at it as a manager, I can say, oh, something is wrong. But then as a person, I have to look at it. If I don't look at it, it can go wrong anyway, because I need the personal view of someone. To the contrary, you could have a digital twin that takes out the parameters of operation, sees that something is going wrong, and create a work order to basically correct it without any person looking at it. So it's both. but it's something about it, So the definition of digital twin for building operations is something we really have to redefine, I think.
I think there's a modest role for BIM in the digital twin for operating. BIM is it doesn't describe the process, it doesn't describe the systems, it doesn't describe behavior over time. It describes the thing. That's a very narrow definition of BIM, but that's what I would say that's what BIM is. So, but I fully agree with your definition that it's much more important to think about the process and to think about how do changes affect systems,
right,
than it is around having a 3D visualization. Just getting back to what we said earlier, in the 50s and 60s, if people operated a plant, they had a table like this with red lights on it.
Yeah.
So and then
something would pop up.
Yeah, and I mean, they didn't need a 3D representation of the plant to be able to make decisions around operating the plant.
Right.
This abstract representation of the thing is much more suited to do that than a complex 3D model.
I would almost say that for building operations in that frame, a BIM model is actually a form of analytics. It helps you to understand situations as a human. So you're looking at the graph and you make your conclusions out of it, like you do with BI. And it's basically almost in that realm. But you add the localization and the relationships of certain things,
which is also important. I mean,
which is very valuable.
If you have relocations within your building, or you need to take away a column or a bearing wall or whatever, you need to know where it is, and you need to do what-if analysis, just like you did in the design phase.
Yes.
If you take all the information from the design phase and you do in this 30 to 50 years of operations, you want to change a wall or whatever.
Yeah.
You can re-engineer the whole building and then get someone in to calculate whether or not I can take away that wall. If you take all the information from the design phase, you can do this what-if analysis, just like you did in the design phase. You can do it in the operations phase as well.
Which brings me to another topic, and it's common data environment. Because you're moving into that direction of, okay, there's this model with its data surrounding it, basically associated to it, and is basically... Am I right to understand it that common data environment is now predominantly put into the design, construction, assembly phase?
Yeah.
How do you see that propagate into the operations phase?
Well, that's interesting. In the design phase, you need a common data environment to be able to coordinate between disciplines.
Right.
If you don't, then you get stuck in all kinds of versioning trouble and whatever, and then you're simply designing something that doesn't make sense.
Right.
So in the design phase, it's obvious. Just like using 3D models, it's pretty obvious.
Yes.
Handing it over to and then you hand it over. Basically, the common data environment is kind of a description of how it moves into the different phases, ending up in the as-built situation, preferably.
Right.
It almost never happens that it actually is a representation of the as-built situation, but that's
you just talked about it.
Yeah, that's the challenge. But
yes,
I mean, if you are an owner, I think the problem, which is good, we need that. So I don't want to be too critical about it.
No, I know.
As an owner, you should be able to specify your requirements for all the information that goes through these phases. So for me, the big challenge for a common data environment is not storing the right information or connecting the right information. The biggest problem for me is how do I make sure that with every transition from design to final or to construction or to manufacturing, how do I make sure that all the information I need in the operational phase is actually there and is coherent? How do I do that? It's a huge amount of information that people get lost in the quantity of information, the complexity of that information.
Data reduction through the process is, of course, something you must do because you need certain data in this stage. You don't need it anymore there, so get away from it.
Yes.
And the next stage again, get away from it. That's it. Now, another point about common data environment is what I seem to notice, there are different vendors in the world of BIM-like systems. They all have a common data environment. Yeah. So what's common about common?
Yeah, I mean,
how to deal with that?
The common data environment, as described in this ISO 19650, is actually it's a concept, and people confuse concepts with systems.
Yes,
that happens in manufacturing as well. There's product data management. It's called a system. It's even ERP or even CRM. It's very closely related to a system, but it's not necessarily one system. So a common data environment can have all kinds of aspects. Data can live in different systems as long as I control the process overarching these systems, making sure that information moves from one system to the other. So integrating systems and building a common data environment as a concept across multiple other systems, that's the way forward. I mean, replacing every other system by a common data environment and saying this is the common data environment, now this is my single source of truth, is a restriction that's it happened with ERP in the 80s, where ERP said, well, whatever you do, every single bit of data has to live in my system, which is
not a concept you can uphold over time.
So there's a
so we're actually moving from systems that just eat all the data so they can operate to systems that basically interact between each other. Now, if you look at common data environments then from an owner-occupier position, so the people running and operating using the building over the life cycle, I imagine, let's say you're a multinational and you have multiple buildings all over the world and you want to do something about common data environment, then basically part of it, that would be your common data environment, not that of the designer constructor in that area, but they need to connect to your CDE.
Definitely. So think about systems integration. Think that there's APIs in the world. So how do we integrate those systems? How do we map those systems? And more importantly, how do I make sure that if the information moves from one phase to the other, or from one system to the other, how do I make sure that all the information I specified in my requirements is actually there? And if this state transition in a common data environment is crucial. And within those state transitions, you need to make sure that you have an automated check. It's absolutely impossible to check the completeness and the coherence of BIM data in a manual fashion, even if you have tools that someone operates. Within this, if you're an owner, make sure that you have an automated validation system in place that checks whether or not your information from the design phase or the construction phase is handed over completely and correctly into, and it also allows you not only to validate the information, but it also allows you to consolidate and to restructure the information to fit the operational processes.
Well, Paul, actually, I must say, we had a full list of questions. We didn't touch on any of them, I guess, today.
It always happens when I talk to you.
It was a great conversation today. Just one question to close it off for today. If you were to be a owner-occupier, a facility manager, a real estate manager type of person thinking about BIM adoption, what's your dominant advice?
Specify what you need and specify it in a smart fashion so you can actually do checks and validations in an automated fashion. So make sure that you have a validation system in place that can check whatever you want or wish for in an automated fashion, because else you will be lost in complexity and lost in the huge amount of data.
Well, Paul, that was great advice. And it was a great conversation.
Thank
you very much for this. And anyone who would like to get in contact with Paul, I think your website, Kdeck.com, is there. And feel free to contact them. Thank you very much.
Thank you. I enjoyed it.
Me too.